Welcome to Unleash Your Inner Game Dev. This is week 2 of our mobile programming course, and I'm Jamie Bentley, and we'll be starting very shortly. All right, this week we're going to be starting with the basics of coding. All scripts in Unity can effectively be applied to objects, and they can intercommunicate, and they are a very efficient and quick way of optimizing games and the game logic, which may require quite a lot of customization in order to improve the gameplay. And you can expose lots of the parts of your code so that it can be easily modified without having to resort back to coding. Now, code is basically built up of variables. Everything you do will reference something, be it a number, an object, or a position in space. So whenever you do coding, everything is stored as a data type. Some of these data types, which you'll use most commonly, include integers, which are whole numbers, floating point numbers, which are decimal point numbers, vectors, which are collections of floating point numbers, often used for Euler angles and Euclidean positions, such as your x, y, z positions, pointers, objects, and transforms, and several other things which we'll be covering in this lesson. Everything you do within code is typically done through what's called a method, also known as a function, depending on where you come from, be it from a C background or a C# background. And most things you do will be triggered from your own code, but there are certain things that are triggered automatically by Unity on objects. These are all inherited from mono behavior, and by default, it will automatically trigger its own methods. And these are awake, start, lead update, on enable, and various other ones for triggers and physics-related things of that nature. So the main thing we want to do with Unity, especially when you're making a game, is movement. Most games have some form of movement or user interaction. And in 3D space, we typically handle this with an X and Y, Z position. And this is always done through the transform component. Every Unity object has a transform component. So this is always there, always very easy to access. Now there's a few conventions for moving objects. You can manually alter the position in the update loop, and an update loop is called every time a frame is rendered. Typically this is 60 times a second, depending on your monitor. Unity also has a PhysX integration, and that is usually accessed through what's called a rigid body. A rigid body will do a lot of motion for you automatically, including collisions. It will handle bouncing, things bouncing off each other, things floating in water, cannons, rockets, missiles, things of that nature. And it can be a very quick and efficient way to prototype code. However, it does have some other issues where it tries to make things move with relative accuracy in terms of real life scenarios. So you might notice in older school sort of first-person shooters, the characters can move on a dime, which is not necessarily realistic. So sometimes it's not suitable for your needs, but other times it's perfect, for example, a car simulation. Other sorts of moving objects are things in your interface, buttons that move and slide on, etc. Animation is another very complicated form of movement, but that can be entirely handled without handling code. It can be handled from Blender, 3D Max, Maya, or through Unity's own animation tools. And of course, Bones, which is very similar to animation, except it then affects a mesh. So the basics for all movement comes from input. Now, there's quite a few different ways to get input into a game, and this can be from touching the screen, or if you're doing PC, it can be from mouse or joystick, or of course steering wheels and keyboards and things of that nature. Now, Unity has what we call the input manager. The input manager is a way to simplify cross-platform work. For example, we have what is called an axis. An axis can be up, down, left, right. It's quite agnostic in that regard. So you will have a horizontal axis, and on a PC, that means to move it left, you would push the left button, or left arrow key, I should say. On a controller, you would use your thumbstick, but they're both affecting the same axis. The beauty of this is it means you can use the same code for both platforms. This also carries over to mobile just fine. So there are quite a few basics for handling input. Unity has what is called the cross-platform input manager, and it handles quite a lot of the integration between iPhone, Android, and PC, console, etc. And this allows you to get several different kinds of input in one simple script, as I've shown in the script here, which would be for a car. Specifically, if you fire a button or you press a button that you have labeled the drift trigger, you could enable a drift. All right, so the first thing we need to do is find out what the user is touching. And to do this, we're going to jump over to the example art that's been provided for this week's course. And at this point in time, this project is very clean. It doesn't do a lot. The only thing it should do when you press play is sit still, and you might notice that the penguin is very slightly moving because it is animated. And this penguin has a few different animation modes. It has jumping and running. And today we're going to focus on getting this little guy to run around the scene, have a camera follow him, and that will be driven by input from either touch input or via your keyboard. So the first thing we're going to want to do is add a script, and I've just started one called Penguin. It's just an empty script, which is with create C# script, and it's Penguin. I'm then going to apply it to the penguin, which we do like this, drag and drop. So straight away you'll see down the bottom that we have a penguin component added to the penguin. So this is the default script that Unity has given us. It just handles start and it just handles update. Now, already included inside this project that has been provided is the cross-platform input manager. It's a standard Unity asset, but it doesn't get included into scenes by default. So because of that, we need to import it with a very simple line of code, which would be using Unity standard assets dot cross-platform input manager. And it appears I haven't imported it, so I will just jump over here. Now, if you're looking to import it, because the project does not have it, you can go Assets, Import Package, Cross-Platform Input. It will now bring that up, and we'll just include the whole lot because we will be using the thumbstick functionality of it. So that's now been included into the standard assets over here. We just, reload. Here we go. So now that's now working. No, it isn't. Just going to make sure I haven't made a typo. It does not appear to be working. 1 second. Right, using Unity standard assets, cross-platform input. There we go. So I must have just typed something wrong there, but we're all up to date now. So now we have that imported. The first thing we're going to need to do is, I'll just take us back to the penguin for a moment. The penguin, for moving, we're going to move it by pushing the rigid body 2D around. That is this component right here, which is a rigid body. It comes in 3D and 2D. This is going to be a 2D game. And I've just set it all up accordingly for you. And it does have a constraint on it, and that is I do not want it to rotate on the Z axis, which is this axis here. I want it to always stay facing upright. So that's what the freeze rotation with the Z checkbox does. So very quickly, first we're going to need a speed, and we're going to do that with a floating point, which will be a public float. And it will be movement speed. We're just going to set that to a default of 5. Now, when you set this variable as public, we jump over to Penguin. You'll see down in this area that this is now exposed into the Unity inspector. So we can change that, and we'll be able to change that as we play. So now, most importantly, we need to cache the rigid body component so that we can access it with relative ease. This doesn't need to be a public object or a public variable, so we can just type rigid body 2D, and I'm just going to call it RB for short because that's quite easy to remember. So that's now declared. So we'll call these private variables, and we'll just separate here. We'll make these for editing in game. Now, right now that's a null pointer. It doesn't go anywhere, it doesn't do anything. So what we need to do is make sure that it actually points to where it's meant to. So we do that with a get component because we know the component is on the same object. So now whenever we call rb dot whatever, it will now begin moving appropriately. So now that that's working, we can test this quite simply. What we're going to do is get a temporary speed, or a direction actually. So we're going to do a float direction. Now I should point out that anything declared inside a method is within the scope of that method only. So this direction method I've just made cannot be accessed inside the start or in the inspector or anywhere else. So now I need to use the cross-platform editor, and we're going to do that by setting the direction to be the same as the cross-platform input manager. Sorry, typos. Get axis, and we're going to use the horizontal axis. Why is that not working? Let me just check that for 1 second. There we go. Just having a bad day with typing. So, the direction will now match whatever that is. So we can see what that is in real time simply by debugging what that is. So we'll put direction equals plus direction. And this is just going to output the string to the console. So now we'll save that, jump back in, have a look, and you'll see direction down here. I'm pushing left, I'm pushing right. So now we have the basics of input. Now once we move this into a mobile space, which we'll do soon, we'll be able to do that via touch input. And if you're really feeling adventurous, you could possibly do it via the accelerometer. So first things first, we want to move it. So what we need to do is take a poll of the current penguin's position, which we would do with vector3, new pos equals rigid body dot position. So this is the current position. New pos is now the position of the penguin before we change it. So now we need to modify that, which we can do with new pos.x. So our vector3 has 3 axes. It's x, y, and z, which is handy for x, y, and z positions in 3D space. Because we're dealing with a 2D game, we're not going to be using the z at all. So now we have new pos.x plus equals, which gives it it adds a number to it, which in this case is going to be the movement speed times the direction. So if this is -1, if direction is -1, it will automatically make it go left or right. And then we're going to times that by delta time. Delta time is the time since the previous frame. So whenever you're doing anything you want to be frame rate independent, you need to use delta time. This becomes incredibly important if you are running on poor hardware where you can't rely on 60 frames a second. This deals with that. If it's been 0.2 seconds, it will move 0.2 distance. And it's very consistent and it's very reliable, so I highly recommend you use it for everything. So, our penguin is not moving, and I need to put... Oh, one thing I probably should have mentioned is there are 2 update loops. Update is updated every frame. Fixed update is updated every physics step. Physics in Unity aren't necessarily done in the same time sync. They're done asynchronously to your frame rate. So you can do all this code inside a fixed update without any issues. So what just happened there was my penguin didn't move because I have changed the position of new pos, but I haven't told the rigid body that the new position should equal the new position. So this now sets it. This sets the rigid body position to new pos. And if this is getting a bit hard for you guys to see, there we go. So now we hit play. I hold right, he moves right. I hold left, he goes left. Now the beauty of this is if I want him to move slower, I can do so by changing the movement speed here, and I don't have to make any code changes to do it. As you can see, he's now moving quite slowly. And if I make it 10, he'll move very quickly, which, looking at the screen, you guys might not be able to see that, but you'll see it in the YouTube video. So that's the basics of getting input from the cross-platform input manager. We may also want to check for a jump, which we'll do with another one, which we'll just add just down here. So we'll call this check for left/right movement. The other axis, of course, is called the vertical axis. And these are all set. I'll just quickly show you where they're set. Inside Edit, Project Settings, Input. And here you can see the axes. Horizontal can be moved by the left button or the right button, or A or D for your WASD controls, which is quite common for first-person shooters. And the vertical is up, down, SW. So now that we've done that, we need to add a jump delay, which we'll just quickly, I'll show you the quickest way to do it. So just down here, if updir is greater than, say, 0.5f, which means that they're pushing up and we want it to go up, we will now change the velocity, which I'll do underneath this to make it just a bit clearer. Add jumping velocity. So now we take the velocity that we have, vector 3, current velocity equals rb.velocity. Now velocity is similar to position, except it represents the change per axis on every frame. So if we now do, current velocity dot y, and then we just say it equals 20, just for the sake of ease. And now we reapply that, equals current velocity. I should have called that new velocity, but you get the idea. So now, when I hit up, or even when I don't hit up, that's because I haven't done this. If the updir is greater than 0.5f, so between 0 and 1 is the full extent of that axis. So if they hold it for more than a small bit of a second, it will now make the character jump. So he'll fall, push up, and he jumps. He jumps very high, but he does jump. Now there's a few reasons why you would not want to consistently do it like this, and that is the longer I hold it, the further up he'll go. And what we'll do later on is we are going to make sure that he can only do it when he's touching the ground, because otherwise he can effectively fly. So that is the very basics of moving the character. And then as we go, we're going to tidy it up a bit with a bit more movement. But first, I'm going to do a line of questions, and then we'll move on to the next bit. Margie, do you have any questions for me?
Sorry, just had to unmute myself. So we've just got a couple. Firstly, Alan would like to know that what's the difference between the uppercase and lowercase methods of game objects?
Right, so I'll just quickly jump back in and show you what those are. So the capital here is a type. The C# standard, it varies from company to company or wherever you work, but usually you define a type or a class with a capital letter. So a rigid body is a capital R, but if you were going to name it a variable, it's lowercase. So your type is uppercase and the actual variable name itself is lower.
Cool. Second question, are update and fix update only for clarity, or do they have a specific function?
They do have a very specific function, which just reminds me this should be fixed delta time. All right, so it's kind of difficult to visualize, but update, let's for the sake of ease say your computer or phone renders exactly 60 times a second. That means that update is triggered 60 times per second. Fixed update is run on the physics loop. And the physics loop is controlled from within project settings time. And it runs every 0.0166 minutes. Well, that's what I've got it set to, which is 60 frames a second, but that can be anything. I can run that, 0.2 if it's running a bit slow. I can do that and I'll get a bit of additional horsepower. So they're asynchronous to each other. They might not trigger at the same time. So it's quite common that things that don't use physics don't use fixed update. Things that do use physics need to use fixed update because you don't want to send messages to your physics engine that are out of sync with its physics step. So moving or altering a physics object is done in fixed update, not in update. That's the primary difference.
Can all objects use physics and frame timers?
Yes, they can.
Okay.
Okay.
Last question.
I'll clarify that a bit more.
Sorry.
While the physics step is handled in fixed update, you can use fixed update for anything you want, but you might find if you're running your physics at only 30 frames a second, it means it might be stuttery if you're doing like a gradual movement. Now, this is relevant because if we jump over to, say, this little guy here, you'll notice that on the rigid body setting itself, I have interpolate set to extrapolate. That's what the rigid body will do in between its physics steps when it's still rendering frames. So if I set it to none, it will only update on the physics step, so it will stutter if the frame rate is higher than the physics step. So you set it to extrapolate or interpolate, depending on the responsiveness you're looking for, and that's why you do it that way. So if it's not physics, I don't recommend doing it in fixed update.
Last question. Can you please explain about 0.5 value conditions while assigning the jump statements?
Oh, yes, I can. So the reason I did that is because the axis is not an integer, it's a float. So if you push up, it has a velocity to it. Even on a PC keyboard, it will not hit 1 instantly. And the reason I did it greater than 0.5, it's like you would typically call that your dead zone if you're doing a thumbstick or an on-screen thumbstick. It's the same thing. So you don't want it to trigger too early. Like if the breeze touches it effectively, you don't want it to trigger a jump. You want it to be a deliberate amount. Sorry, I'll just jump into Unity. The speed at which the axis is modified is actually set within the input handler itself, and you'll see gravity here. So I can change that to be a different number and it will be very quick to get from 0 to 1. I should probably point out that typically for jump, you wouldn't actually use an axis, you would use a button instead. So it was possibly a poor choice. So for that, just very quickly before we jump into the next section, which is actually a continuation of this section anyway, so what I would do here is instead of doing it that way, is I could just do a regular, not a cross-platform input for the sake of ease, get button down, and then we do keycode dot up arrow. And one extra close bracket. What have I done differently? If input get button keys. Yep. It's not a string, get button down. It's not meant to be a string. Sorry, get key down, my bad. There's quite a few different ways to do things in Unity, obviously. So now I just push up once. So he's jumping a bit too high. Let me just quickly change that speed to an actual jump speed, which we'll do right here. We'll call that a public float jump speed. And what did I have it set to? 20. Let's make it 5. So now link from that to that. So now when I push up, and I'm just pushing it up, and the keys have 3 phases. There's down, being held, and being released. So now I push up and push, etc. So now it's not based on an axis, it's based on every time they push up instead, rather than relying on, say, a thumbstick. Hope that clarified that question for you. I know it was quite a long answer.
Thanks, Jamie.
All right, so we're going to move on. And in the next section, we're actually continuing on from this, but I'm breaking it into we're now going to start finessing the movement a bit, and we're going to start tidying up the jump. So now that the character has the basics of input being handled, we're going to very quickly need to, well, for starters, when I push left, you may have noticed he still faces right, which if I just wait for the frame rate to update, there we go. So the good thing about 2D games is that sprites have a particular render order. So you can rotate it round and they still render the correct ones on top. It's very handy. So when I set the direction, I can now just change the scale accordingly. And I'm going to do that with a very simple system with transform. So now we're going to, I'll just zoom in for you guys, set the direction of the character. So we know which direction we're heading. And based on that, we can change the direction that the character is facing by changing its X scale. So by that, we're going to do if direction is greater than 0, which means it's going right, because 1 is right, -1 is left. We then know that we want to do transform.localScale equals new vector 3, 1, 1, 1. If it isn't doing that, I'm just going to very quickly, oops, sorry, wrong line, is put a negative in front of it. I'll hop back to that, don't worry if you missed it. And now, depending on the direction he goes, he at least points in the correct direction, which I think is, quite helpful. So the next thing we're going to do is we're going to tidy up the jump a little. And there's quite a few different ways to do this. Some people might like double jumps, some people might not, but effectively what you want to do is make sure that you're on the ground before you jump. Now, for the sake of ease, I've already got the bit of the manual open for this. What I didn't show you earlier, just before I jump into this, you'll see these two circles on the penguin itself. These penguins are colliders. In this case, they've been added directly to the penguin object, not the sub-object of feet, hands, head, etc. And they're just sitting there and there. And the reason they're done that way is so that there is, particularly with circles, is so they can walk up ramps without clipping, because a box collider will clip. A circle collider is a bit more lenient on friction. And the top one is so if something hits him in the chest, he can still react to that. Now, this is the Unity documentation, and it even has a beautiful little piece of example code that you can just copy-paste straight into your project. Now, we don't actually need all of these collision points, but it's, sometimes handy to have it. But what we do need is the details of the collision. So if.collision.collider.tag equals, and for those of you playing at home who have the project open, if we have a look at the piece of world, you'll notice it's not tagged. We want to tag it, and we're going to tag it with a new tag that we're going to call terrain or ground. Let's call it ground. It's easier to type. So now I'll put him on the ground tag. Sorry, let's do this. Let's remove all this because we're not going to be needing that much data. Tag equals ground. So now let's just check if that works with the debug.log. We hit the ground, exclamation mark. So on collision enter is also called from monobehavior when two physics objects, one must have a rigid body when they collide. This was covered in the last tutorial, but we'll be using it in a slightly different way this time. Last time we explicitly let the rigid body handle its own collisions. Now we're going to start using them a bit more in a custom way. So when we hit play, we notice that it hasn't actually collided. with anything just yet. Player. All right, let's just break that in two. Let's remove the test in case it's not properly tagged. And the reason this isn't working is because I've done it with the 3D method on collision enter 2D, which is actually slightly different. Collision enter 2D. Let me just bring up the contents of that for you so we can copy paste the same code, because you'll find that it's exactly the same system that I'm doing here. It's just got the word 2D on the end. However, it does also use a different class for the collision. So now we have this. We'll change it to ground. Excuse me while I just change that. And debug.log. Hit the ground. So jump over, jump back in, hit play, and you can see that we've hit the ground. So now that we have hit the ground, we're going to have a constant state running, and these are penguin state. So we need to keep track of how the penguin is behaving. So we'll call this one is grounded, and is grounded means that it's on the ground, and by default it is false. And what we can do here is, if it is grounded, we add that to the get key down. So now both these conditions must be met before the character is allowed to jump. And when it jumps, we say that it isn't grounded. Very simple stuff. And we're going to do the same thing here. When it has hit, we want to say that is grounded. It is now true. So let's just hit play, make sure it works. I jump, but I can't jump when I'm in midair anymore. Because let's find the penguin object. You'll see down the bottom here, if we change this over here to debug, it will show our private variables that are not editable. You'll see this very bottom one is labeled is grounded, and right now it's true. And it becomes untrue the moment I jump. And this is the basis for pretty much all character interaction and moving about. So that is a slightly more detailed look into character moving and another way of getting your characters to jump. Now, for more complicated games where, for example, cars or other sort of things, you might need substantially more complex systems in place to handle jumping. But for your standard platformer, this is absolutely acceptable and very quick to turn around. So just before we move on to the next section, I will take a couple of questions.
Hi, Jamie. I'm not sure if this student is referring to your current demo or a different demo, so let's see what happens when I ask this question.
Okay.
Eagle gets a main camera script missing error. Do you have any ideas which script should be linked?
Let me just.
Or is that a forum question?
I'm not entirely sure. Did you say Eagle camera or the camera?
Eagle, a student, is asking.
Oh, sorry.
He gets a main camera script an error about a main camera script being missing.
That sounds like the last tutorial there was no script on the camera. Earlier when I was making this lecture, I was having the camera chase the character around. That might have been submitted with the demo project. To remove it, you can probably select the main camera and simply delete the missing component reference, although I don't have it here and this is a fresh copy of the project.
No worries.
Post that in the forum and I'll have a look into that for you.
Next question. Can you manage both 2D and 3D objects in the same game or scene? And what is the overhead in doing so? Are there any example cons of doing so?
The quick answer is yes, you can definitely do both. The downside to all of that is 2D colliders will not hit 3D colliders. So a very common way to do games, for example, Super Mario Kart, maybe not the latest Mario Karts, but Mario Kart is effectively a 2D game, but it's in 3D space. So if you imagine you've done all of your game code as a 2D game, it's top down, but then you're just translating all those figures over into a 3D track, that's a good way to sort of mix and match. And it's, while Mario Kart itself might not do that, that's Nintendo proprietary technology that no one has ever seen. It's definitely a good way to do it. And yes, you can totally mix the two, but just remember that Rigid Body 2D and Rigid Body 3D and the colliders will not interact.
In what conditions can we use collision instead of 2D collision class?
Oh, right. So the collision class instead of collision 2D class is the exact same thing, but for the 3D physics system.
Okay. And so someone has just asked, why use the triangular brackets around rigid body 2D?
Where did I do that? Triangular brackets around rigid body 2D.
Probably
here,
closer
yes,
to the
that's,
start of it.
yep, that's here in the start. This just gets it searches for the type with get component. It's just the C# bit of syntax. There are other ways to do it, which I'm not that familiar with because this is the way I've been doing it for some time, but I believe you can get it via string with I think it's like get component, and then you can actually call it via its name, which I don't recommend because it's a string search, but that can be handy if you have more than one component running, etc. I would just quickly, let me just bring up the menu to show you the exact C# nomenclature for that, because there's probably quite a few overloads for it. It's taking a while. Well, when in doubt, get component. It will accept quite a few different ways, but this is the way that Unity prefers you do it. But here you go. You also can do it without the greater than and less than signs by doing a string search like I did. I did it with the triangular brackets again, but that's not required. That may require casting, however, which you'll see they've done here. They've called it a hinge joint. So it's a hinge joint called hinge, and they get it from a component, but then they're casting it as a hinge joint because it's not implicitly called or casted without the less than, greater than signs. Next question.
No worries. Last question. How do you get the colliders to, sorry, the screen just shifted. How do you get the colliders to interact with each other, for example, balls on a pool table?
That's actually handled by Unity's physics system. It can be handled by you, or it can be handled by Unity's physics. I should point out that if I turn off all the code in my Penguin, so all that's left is the default rigid body plus the colliders, he is actually just sitting there by himself. That's a codeless solution. I can now even move it, and he will just respond to that. And that's one of the beautiful things about rigid body 2D, or rigid body in general, is that it can potentially do quite a lot for you. If I do that really aggressively, he'll fall through it. Hopefully that shows up somewhere. Yeah. So yeah, for something like a ball, you would simply add a physics material, which is actually on the collider itself, and you can see that here. This was also covered in the last tutorial. All the rigid bodies in the first tutorial had a physics material applied that had a high bounce. This guy has no bounce because I want him to actually sit on the platform.
No worries.
Okay. So the next thing we're going to touch on is prefabs. Now, prefabs are the backbone of everything modular about Unity, and they also serve a bigger purpose when you're working in a collaborative environment in that, excuse me, scenes cannot be edited by multiple people at once, and neither can prefab. However, one of the benefits of prefabs is that because they can be made to be just small pieces of your scene, they can be edited separately. So you can have one person working on the level, but all of the prefabs can be updated via Git or the asset server, etc. So right now, this piece of world that you see just sitting in the scene is just a one-off object that I've dragged in. It's a sprite with an automatically generated polygon collider. we want that, oh, and it's also tagged as ground so that the character can walk on it. Now we want that to be more modular, so I can just create it and change it and easily clone it. So we would just drag this and we'll call it piece 1, or piece A, let's call it piece A. Now, all I've done there is I've dragged it from the hierarchy inspector into the project, and it is now its own piece, it's its own file effectively. So now that I've got that, I can drag and drop the same thing many times. So the relevance of this is I now have this object, and if I make a change to this object that's quite severe, I guess you could say. For example, if I add if I add something else to it, for example, I clone it and put it inside itself, and I make a little miniature platform and it sits off the side, this piece A up here now becomes, it's unique because I've modified it. But if I hit apply, all the other objects, which have now been offset, but they are now all the same. Now, what I did there was called a nested prefab, which is probably a very bad way to do it. So I'm just going to delete it and we'll do it again. Oh, there you go. So you can see that each piece now has the same thing. So every time I modify this, it will change across the entire game. Now, sometimes you might want to start with a base prefab and then modify it. That's okay. If I change this prefab, that is now unique to this scene, but not unique to the prefab. It will become unique to the prefab and thus across the scene if I hit apply. And you'll see that's now updated to all of them. So this is quite a powerful tool. And if you were to have, I'll just show you another potential use of it. I'll just go back to one good old piece of level. Now the penguin itself is now a complicated piece of machinery, effectively. It has a penguin script, it has rigid body, it has quite a few things on it. And I've actually already made it a prefab, so I'll just remove that. Now it's a new prefab. So the benefit of this is one prefab. Now I just drag another one, has all of the same controllers. So now effectively, I have two penguins that behave, they are technically independent. So you'll see one guy has now gone down a platform, but the other guy hasn't because it's responding to the input and not the other penguin. They are totally independent penguins. And so that's one of the benefits of prefabs. So another, what we'll be doing in the homework today is, while this is a single piece of world, I've actually supplied heaps of other bits of level art. So there's quite a few different pieces of art to work with, and you'll be encouraged to build a scene of your own using this prefab system, and also getting the penguin to sort of run around it and do its thing. So that's the power of prefabs, and I highly recommend it. So if you're going to commit that to a Git repository, if you're working with friends on a larger project, you must commit the meta file that goes with it, otherwise it will lose all of its links. And the other thing which isn't documented, and it's not very clear in the way Unity does it, if I modify this prefab, I must save the scene. Otherwise those prefabs aren't updated. You don't have to change the scene, but you do need to save it, and that then saves all of the prefabs that you've modified in that scene session, if that makes sense. So that's the basics of prefabs, and that's, I think, pretty much all you need to know about prefabs, at least in the early stages of, project development. And next we're going to move out to decoration, and then we're going to take what we've got and then make it a little better looking. We're going to flesh it out a little, and we're also going to add some animation to the penguin, so the penguin sort of animates and moves about. And we're also going to put, actually, I didn't build a section for it, but I'm going to quickly cover it just before the end. We're going to use the thumbstick system that's provided by the cross-platform input manager so that you can then get this to work on a mobile device, because right now this is only working with keyboard presses, which obviously you don't have on most phones. So I'll quickly take some questions before I move on to the next piece.
Hi, Jamie. So first question, how do professional game development teams keep up to the schedule on big projects such as the SpongeBob game? Hello?
Yeah, sorry, my microphone turned off briefly. Yeah, they get through it with
No.
really big lists and agile development systems. For example, Jira is a very common one, or Rike. Sometimes people just use Google Docs. I mean, there's plenty of ways to do it, but effectively, especially getting towards the end of your milestones, and games are usually broken into prototype, white box levels, which is where you fleshed out the game, but it doesn't necessarily look correct. Then you start polishing graphics. Each company would use its own methods, but effectively, at some point, usually in the last 30% of development, testing begins asynchronously in a separate thing. So then, while some developers will still be feature adding, some of the other programmers might just be grinding through bugs. And this can take as long as your budget allows, basically. For example, a Bethesda game, for example, Skyrim or Fallout, they're very large games and they don't have infinite resources to test it all, so their games are sometimes a bit buggy on release, but they get there eventually and they do, after some time, become quite solid.
If I have an entire world, 2D or 3D, how is it possible to show a minimap in real time? By linking minimap movements to real games, I think to delegates or similar, or by retrieving directions of the input and applying them both to character and to the minimap.
Yeah, so that's not the simplest of things to answer, but if, for example, if I just pick a game, and I'll just quickly find I'm going to pick a classic game, so it's quite pixely and thus easily to see. Here we go. I've picked Dune 2, which some of you might know. Come on, internet. Okay, that picture hasn't worked. Okay, so the summary is you have data for everything, and you need to consider the minimap the moment you start designing your game. It's absolutely critical that you know from the start exactly how it needs to work. So with Dune 2, for example, and this is the classic Westwood strategic sort of real-time strategy, they knew the position of every player and they also knew the tile. So each tile effectively then got rendered as a single pixel in the bottom right. And effectively they took all the data they had and then they just updated it progressively once every couple of seconds because it wasn't real time. They didn't have the processing power to crunch through probably quite a few thousand tiles at a time. So you would find that the background would be done once and then only updated for the fog of war. And then in real time, because it had a unit limit of approximately 255 units, it would draw the corresponding pixel in the bottom right. This worked particularly well because these were all fixed resolutions. So we don't work in fixed resolutions anymore because there's too many different kinds of monitors and devices. So effectively everything becomes float. For example, if we have a look at the minimap, you could probably assume, let's call the level 1 2 kilometers wide. So 0 would be left side, 1 would be right. So effectively you're just converting that in the fly and you would render it with a separate camera. You can have multiple cameras in Unity rendering at once, which is what we're about to do. And that would be how you do your minimap. For different kinds of games like races, etc., where you want a 3D map, there's heaps of variations on ways to do that. But effectively you're taking data you have and scaling it down. You might not render it with the same sprites, but the data is effectively the same.
Sorry, is that the end of the answer?
Yes, sorry, that was quite a long answer, I know.
No worries. So how are the multiple penguins moving independently?
Okay, that is easy to explain. So let me just jump back into Unity, which is right here. The reason the penguins were moving independently is because they're object orientated. So this penguin script, and now I have 2 penguins, these 2 objects are entirely independent. They don't need each other to work. Now, so when you see this penguin script, which blah, 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 it can run totally independently. There's not one fixed update per game. There's one fixed update per script. So you can have 30 update loops running at a time. I don't recommend it, but you can. And that would be why, because the input is the same because it's coming from a different source, but the way it responds is totally unique to that rigid body. Now, you can also, we could link it by changing, for example, let me just, actually that would be a bit long-winded, but you could link this rigid body to the other penguin. So I'll just go rigid body 2D, another rigid body. And I'll just make that one public so we can see it in the inspector. And this is something it's not being touched on this tutorial, so this is a bit off the cuff, but we'll get the general idea. You see the penguin down here. Now we hid the original rigid body link. This is called another rigid body, just here. And I can drag the other penguin, which is penguin 1, into that. So now it is linked. So if I wanted to affect the other penguin from this script, I could now do that in here somewhere by doing something. Actually, yeah, okay, so I'll make it jump at a different speed, so which is effectively the same thing, but just trying to think of the quickest way to do this, sorry. Move the other rigid body, and I'll just put this one back up here because I don't want it. So another rigid body dot velocity equals current velocity, and to make sure we realize it's a different velocity, I will take the velocity of 1 and then multiply it by 2. So he should jump twice as high. So he's linked, and I'll just, because the other one won't have it linked, I'll make sure it does not equal null, because otherwise it will throw an error, which is handy because you don't want things pointing to nothing in game. I'll just quickly clone this so he has somewhere to land. All right, so they now both fall, and when I push 1, the other jumps twice as high, because this penguin on the left is now telling the penguin on the right to jump the same distance, and then, let me rephrase that, both penguins jump independently, but then the left penguin is also adding to the velocity of the right penguin. So now they are linked. And I've just got to quickly get rid of all that code before we move on to the next section, because it will be quite confusing. And I will now take the next question.
When you are working in the scene, you have your prefabs unattached to each other, but when the game starts, the penguin is neatly standing on the platform. How do you ensure all your prefabs are where they need to be when the game starts? Is it purely using the XYZ coordinates?
Oh, right. So he's actually not starting directly in the platform. That's the frame rate deceiving you. When I hit play, he actually drops into position. There's a few different ways to do it, but typically, yes, you would set it explicitly on start to start in one spot. For example, let me just get rid of our multiple penguin army. Select this little guy here. And if I freeze his Y position, so when you hit play, you guys can now see that he doesn't fall because I've turned off gravity for him. I can still move him left and right, but he's effectively working without gravity. So if I turn gravity back on, then he goes. So you guys were just not seeing him drop because of the frame rate of the webinar software, that's all.
No worries. Thanks, Jamie.
All right. So in this last section, we're going to handle specifically with things to pretty up the game. Now, probably the first thing we're going to want to do is, for the sake of ease, we're going to make the camera a bit bigger. Now, because it's a 2D camera and 2D cameras do render a bit differently to a perspective, we can still render in perspective, which kind of makes our game view very interesting. So if you were to do a 2D game but then move the camera, you'd get a little monster like this. Let me just turn gravity back on for our penguin. That could be quite a unique little game idea right there, but we're not going to do that, cool as that is. We're going to just quickly jump back, but that is an option. So we want our camera to still render orthographically, which means 2D, but we just want to make it a bit larger. Now, one thing we've not touched on so far is multi-camera rendering, which comes on to that question I had earlier about minimaps. So when we zoom out, by default, you can see the camera and you can see the extent of the scene. So for now, I'm just going to take this one little bit of scene and prefab. Now, for the homework, I highly recommend you guys get extremely creative and maybe even bring in the default 2D toolkit that comes with Unity, so you can put the camera follow system, so it will follow the penguin around, which we'll probably be touching on next lesson, but cameras can be very long-winded to get the movement that you want. So now we've got this scene, which we'll just quickly hit play on. Now, at the moment, the scene is rendering with the default background So, and I've just still got the gravity off on that penguin. There we go. So now we can run and jump, and he doesn't quite jump high enough. I don't think I'm going to be able to make it back up. Yeah, can't make it. So thankfully I can cheat and just change the jump speed here. But so once again, this all comes within the, editing your game on the fly without having to modify the code. So now that I've done that, what we need is a background. Now, what we haven't touched on thus far is multi-camera rendering, so I'm going to quickly do that now. So by default, Unity renders as many cameras as you have. Right now, the clear, let me rephrase that. So you have many kinds of cameras, and a camera by default clears the background. It doesn't need to. So this one is just clearing with a skybox, and it's set to blue at the moment. You could change it to a solid color and change it if you really wanted to, which, that would get you through if you're doing something very, old Super Nintendo style. But what we want to do is depth only. So now this camera is rendering only items that are within its frustum, i.e. things that are just in front of it. It's not redrawing in the background. So the beauty of this is if I clone this camera, I now have two cameras, and I'm going to call it the background camera. And this one is going to do a skybox clear. We need to set the depth to -2. And the reason we're setting the depth is cameras need to render in an order. So cameras with a higher number render towards the front, cameras with a lower number render behind. So we want our game camera to be -1. Usually you'd have your interface as 0, etc. And we want our background camera to render at -2. So it's rendering behind the current one. So now, totally independently of the scene over here, which I'll just make it some whole numbers so it looks a bit tidier. I'm going to go to art. I'm going to go to level art, sorry. I'm going to drag in this background sprite. Now you can barely see this little sprite. And you can, in the game view, you can kind of see it. It's a bit small. But what I can do is I can change the scale of this. And I can make it whatever size I want. So here's my camera. I want it to be approximately that large. So now when I go to game view, it is behind our current view, but it's being rendered on a separate camera. Now the reason this might be important to you is cameras can move independently. For example, if my foreground camera is moving quite fast, it means my background camera could move at half the speed, and then you get what's known as parallax scrolling, where your background moves slower. It's the staple of rendering in 2D games. It's very useful. Now, at the moment, I've just used a gradient, but the other benefit of doing it this way is that I can have quite a complex setup over here. So I can drag a cloud in, I can make it a bit bigger, I can drag another cloud in, I can fade this one out, ever so slightly. Actually, not that way, I'll fade the alpha down. And I'll just continue doing that for a little while. Just a bit of decoration, just around the scene. So now all of these things are rendering behind our main character. So I can hit play, and he can run around, and this is all totally independent of our main scene. So if you were doing a mini-map, for example, in your bottom left, and I'll just quickly grab this camera while we're playing so you can see it in real time with our background camera, you don't have to render a camera at the full screen. You could make it render just in one corner, like that. And that is effectively how you would handle a mini-map most efficiently. You don't have to do it that way. You can project it to a texture and render that onto your interface. But a very good way would just to have a separate camera. And that would be probably the easiest way to do it, to be honest. Now, when you do an interface for scoreboards, etc., that is effectively just another camera that then renders on top. And I saw that quite a lot of you guys had already dealt with that in the first tutorial, and that was, the first week of homework, and that was awesome. And I'll just do another one, and I'll make all of this stuff a child of the background camera, so it's just the scene view is a little neater. I'll just make another game object, which I'll call level. And I'll just put all the pieces of my scene into level just to keep the hierarchy kind of tidy. So now we have our background camera, which we can turn on and off. And there's one cloud that didn't quite get the memo, so I'll drag that in. All right, so now I'm going to very quickly clone that camera and call it the foreground camera. Foreground camera. Now we don't want the sky gradient in the background of that. Wherever that is. Here we go. So this camera is now going to render up here. Now this one just has clouds, but we want the clouds to be different, so I'll just get rid of all of them except for, say, this guy. Clone, 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 clone. And I'm going to give him a higher depth of 0. And I don't want him to clear, I want him to depth only, so now I'm rendering with 3 cameras. So if I take this one object and scale it, you can see that it's now rendering over the top of the rest of the scene. Sorry, the alpha didn't clip then, there we go. So now as I move around the scene, it renders on top. Now this can be done for things that are slightly out of focus, or which I might even have here. No, they're all in focus, but yeah, you can drag things in there and it will just work. So you want to layer your scenes when you're doing platform games, and you can, because these are separate, this can now become its own prefab, which when you're working in a team on a big game is going to be very important. So now I have a background camera. So while programmer A is working on the game itself and possibly modifying the level itself over here, which would become its own prefab, the background camera can be dealt with by another artist or programmer totally independently. You would submit that to your Bitbucket or GitHub repository, whichever you're using, and then you have collaborative editing, which greatly optimizes how you work, and it will make your lives better in the future. So that concludes the course for today, which concluded of input, moving a character, prefabs, and decorating a level, and handling multiple depths on cameras. So I've got further reading on all of those things, which are listed here, and I'm very active on the forum, so just throw forward any questions you've got, and I'll get to them as soon as I can. And the homework, which I'll detail probably with a bit more detail to make it a bit simpler for everyone, but also included, and you guys didn't see it, but excuse me, I have several existing sprites for enemies, bees, a jelly character, and an orange jelly character. Now these will need rigid bodies and colliders, and you can make them work however you want. And also, I've actually forgotten one major step. The character doesn't animate just yet. He has one idle pose. So what we need to do very quickly, and I'm sorry I left this till absolutely last, but we're just going to quickly cover it. We want our penguin to animate. So I'm just going to get rid of that foreground camera. It's a bit messy right now. This penguin, which we'll just have a look at his inspector view, you'll see that he has an animator component. Now the animator is very powerful, and I've handmade the animations just very quickly for this course, but he can run and he can jump, but we need to trigger them because by default a rigid body is just a rigid body. It doesn't understand what animation is. So to make it understand, we need to reference the animator component. And we'll just jump in here for 1 second. So the first thing we want to do is we want to cache the animation component. So I'll do that here, and I'll just zoom in for you guys. We'll call it anim because that's nice and short. Now, like we did for the rigid body, we're going to do the same thing here. We're going to get component, and it's going to be an animator. So now anytime we call anim, it's actually referring to that. Yeah, we'll be referring to the animator. So that should be quite handy. And animator is not part of animation. Well, that's because I typed it wrong. It's an animator. So, excuse me. So the moment we start moving, we want to let the game know that we are animating. Now, the other thing is we need to also cache the current state that we are in. So just in the state, we're going to say last anim. And we're just going to make that idle for now. And the reason I've done this is each animation has a trigger. Now, the animation component is quite in-depth in its own, but this will hopefully fast-track you to being able to use it relatively quickly. But each state, and this is the running animation, the jumping animation, has a method or a trigger to move from one animation to the next, and that's these lines which you right-click, make transition, and then you click wherever you want to go. So from any state, and this is separate, each one is triggered, and you'll see that the conditions for this are called running, jumping, and idle. So when we come over here, we'll just make that a bit smaller for my sake. Now what we want to do is we want to trigger the jumping animation, but we do not want to trigger it constantly every time they hit it, especially if it's not on the ground. However, this guy is sort of exempt to that rule. So what we're going to do is call it anim, and then we're going to set the trigger. Oh, sorry, my typing is woeful today. Set trigger. Then we're going to call it jumping. And just so we know what I set it to, I'm just going to do it like this. Now, there's plenty of other ways to do this. This is just the quickest possible way to sort of demonstrate it. You can store these in enumerations. You can store them as integers. It doesn't really matter how you store it. When you start doing networking and synchronization that way, you'll start using bytes to synchronize your animation. And that's just a fairly efficient way to do it. So over here, if the character is moving, and what we want to do is make sure that the character is moving effectively, which we're going to do right here. So if direction, and we're just going to do a mathf.abs, and all mathf.abs does is make sure it's a positive number. So if they're moving, if the user is pushing in a direction, we want to show that appropriate animation, but we do not want it to set the animation. We do not want it if it's already set to running, because otherwise he twitches and he'll trigger multiple times. So now we can set trigger to running. However, I also need to store that animation state somewhere. Last anim equals running. Now there's plenty of different ways to do it. Don't feel obliged to do it this way. This is just the most easy way to show the concept of storing animations, etc. So, and the one thing he isn't doing right now is idling. Else. So, hang on. Else if mathf.direction, abs direction is smaller than 0.1f, which is we're going to call our dead zone. We could link that throughout as another editable variable, which we've done just there. 1 second. And last anim does not equal idle. We're going to do the same thing, but call it idle. And if everything went smoothly, when we jump back here, and it's going to be very hard for you guys to see this frame rate, but hopefully you can see that he's now sort of running. Jump, jump, little guy. Now, obviously, on more complicated characters, you could have 30, 40 animations. You will need much more complicated code structures to sort of store that information, but that is the general basis of it. You don't want to trigger animations too often, and you just need to keep track of the state effectively. And because it's a trigger, it's not necessarily held. You can ask the animator which animation is currently triggering, but it's a bit more involved, but it is well documented within the Unity docs, but it would take a bit too long for this particular tutorial. Now, the one thing we haven't done, which you are possibly all wanting, is we have not made this for mobile. So inside, part of the cross-platform input manager is that it also has a thumbstick for mobile. So if we go inside our standard assets, cross-platform input manager, and inside prefabs, you will see that there is mobile single stick control. Now, the reason it hasn't done anything that we can't see is because I'm in PC mode. If I go to the build settings and I set it to Android or iOS, both work, It will now quickly convert everything. Thankfully, it's a small scene, so it won't take too long. And you'll now see that there's a thumbstick just here rendering in the bottom left of the scene because it's now ready for mobile. So now as I move this, you'll see he moves left and right, but you will notice when I move it up, he does not jump. And that's because I wired that specifically to the keyboard. I'm not using the cross-platform input manager for the jump. I'm using just regular get key down. Now, there's two ways we can do it. We can bind it to the jump button, which is over here, and it triggers, a jump. Or to be a little more fancy, we can still do the same thing we did last time for the cross-platform input manager, and we can get the axis, and we'll just replace it. Say 3. And we know that's not, remember when we first started and I pulled the vertical axis and he just flew upwards because it was triggering every frame? He now can't do that because we now also check to make sure he's on the ground before it works. So we hit play, left, right. I understand the frame rate's a bit slow on the webinar, but the YouTube video should be pretty tidy. So when you push up, he will jump. Now he doesn't jump terribly high, but that's easy to fix. You select the penguin, change his jump speed to 12, and boom. And voila, you have a working mobile game platformer, very basic, but infinitely sort of amendable, and you have the basis of a platformer that you've built yourself. So I recommend looking into everything I've done, and I will be posting a whole pile of links for you guys to read and tutorials for you to also do onto the forums, and I highly recommend you get into it and start making yourself a mobile game. So I'll just ask one last round of questions before I pass over to Jason Howarth.
Hi Jamie, what do you do different when rendering cameras in 3D?
Nothing. It's exactly the same system. In fact, I can change both of them to 3D cameras. For example, that background camera, which is just there, he's still doing his thing. If I select the foreground camera, which is the main camera, change it to perspective, it is now a 3D camera, which I'm just going to angle for the sake of, and voila, I'm now rendering 3D with a 2D camera.
Is it possible to use a skybox as the background, or do you have to use a sprite?
You certainly can use a skybox. The actual Unity camera supports them natively. So on the camera, you'll see clear flags, and it has skybox. Now the skybox itself is not set on the camera, which is unfortunately a bit confusing. It's actually set inside your lighting panel. I know that doesn't make a lot of sense, but that's where it is. I don't know why. But inside your scene, you can then drag your skybox onto it. When you drag in a skybox, which they usually formatted, let me just quickly Google one for the skybox texture to show you what a typical skybox looks like. And Unity's pretty good at auto-detecting the type. If you imported that, it would automatically detect that it's a skybox, and then it would just work exactly as you would expect a skybox to work.
What was used to create the animations?
Yes, typically, because this is, with the exception of the penguin, this is all from a little title I did for a contract job some time ago. And the animation on this particular guy I did in Unity. To be honest, the Unity animation editor is probably not the most amazing, but, sorry, that's Bolt. It is not, terribly controllable, but you can see here that I can, let me just change it to a running animation. I've individually set the keys for each object. And if I wanted to add another one, say I wanted to duck, or if I wanted to die, on this animation tool here, I would click running, and then you'll see a bottom option down the bottom that says create new clip. And you'd go create, and you would say dying. And then you would animate him dying. And then you can trigger that with the exact same method that we used earlier, except you'd need to add a new parameter called trigger, and it would be dying. And as you can see, just by making that animation, it's already put it into the animator. I just need to be able to trigger from any state with right click, make transition, select that, and just make sure that the condition is set to dying. That's it. He would now die on cue. Next question, please.
I realized I muted myself. Is there another animation editor you can suggest?
Animators typically have their own tools that they just love to use. Mine personally is 3D Max, but Blender has also excellent animation tools. Maya, obviously, no-brainer. XSI. I mean, pretty much any 3D tool that is used for anything has an animator in it. The Unity curve editor basically is very limited in terms of functionality. You can't see the curves that well. It's not terribly intuitive compared to what you'd be used to if you come from a 3D background, but it is fast and that you don't have to jump out, export your animations, etc. and so forth. It's all within one editor. Oh, one last thing I'll quickly add to that. The other benefit of it is each animation is stored as a separate file. So if you do have an artist on board who's quite talented, but you're ahead of him for whatever reason, you can just make a dummy animation that roughly does something. Then he can go edit that independently of you and just update the animation file.
No worries. That seems to be it in terms of questions. If anyone else does have any further questions, please feel free to post them on the forums and we will get back to you about them, or one of the other students will respond to that.